Hello, everyone. Thank you very much for making it on the last day of KubeCon. Are you still alive? Yeah. Still going. Yeah. Very happy to be here today. I'm Stefan Prodan. I'm a Flux maintainer for almost 8 years now. And in the last 8 years, I've been doing a lot of GitOps. And I'm looking for now to vibe GitOps. You know, that's the future. We vibe everything. So yeah, this talk is about how to vibe your way into infrastructure. No, I'm kidding. I'm not going to actually tell you to do that, but we'll see how it goes. First, a little bit of introduction, what's Flux, what it does. I'm guessing everybody here is aware of what GitOps is. So Flux is a tool that you deploy on every cluster, and it synchronizes your whole cluster estate with a desired state which sits outside of the cluster. And here in the first version of Flux, which was many years ago, we were synchronizing each cluster to a single repo. And of course, the desired state is split between what's in the repo and your actual container images. In the latest form of GitOps, we call it Gitless GitOps. We basically decided to use the container registry as a unified storage for everything that makes part of your desired state. That means, of course, the containers, the Flux configurations, the Helm charts, maybe you sign and attest everything. So yes, this is something that the Flux project has been advocating for almost 3 years now, and we have, the beginning of the year, we have made the OCI artifact support in Flux GA. So if you are looking at this to migrate your production systems, now is the right time. All the APIs are stable, and we have documentation and tooling to allow you to do this migration easily. So yeah, you've adopted GitOps now. There are a bunch of challenges. These are some of them, but there are many, many challenges of doing GitOps correctly, right? And I'm going to pick the one in the middle. There is no way out. You are going to be a YAML engineer. You can't avoid it. Like, seriously, I'm trying very hard. I created a couple of years ago a tool called Timony, so you can write with Qlang and generate all the YAMLs. But you'll still have to read them, review pull requests. You can't get away. So maybe we can vibe code YAML in the future, right? So you don't have to type it. So part of this challenge I'm trying to address with what we built in Flux MCP. I am going to talk a little bit about that. Another big challenge for most organizations is this trade-off between, should I go with a monorepo and everybody should collaborate on a single repo, all the apps in there, all your infrastructure and so on, or should I go with a repo per app, a repo per team, right? So there is no right way to do this. The good way to do this is by looking at your organization, figuring out how you are structured, how your team are collaborating, and then you can go and build your desired state in a form that people can collaborate on it. They don't hate each other, but they'll hate each other anyway. It's YAML, right? They'll like, is anyone here eager to review a pull request with 10K lines of YAML? No one, of course. Yeah. Another challenge is around signal-to-noise ratio. We know very well. We work with distributed systems. They partially fail. They get degraded. You get a lot of noise with alerts and so on. It's hard to figure out, is it really in a failed state? Will it go worse? Will it recover? And when you put GitOps on top of the cluster, you get more noise in a way, right? Because you have the Kubernetes controllers, the built-in ones. Now you deploy Flux, which comes with 7 controllers, 13 CRDs. Many things can drift, right? How you determine if this drift is going to end soon or it will be an infinite drift and so on. And especially on this side, I think this is the true value of what we can do today with MCP servers, where used correctly, they can increase the signal to noise ratio. But let's focus first on how we solve the YAML problem. So, of course, you can go to any AI you want, and you can ask the AI, please be my YAML engineer, and help me out of this hell. And it should be able to do it, right? LLMs should be able to do this. Yeah, it's YAML. It should be simpler than code. It's data. It turns out it's not actually simpler than code. But I did a test and see the latest LLM, the latest version. Does it know anything about Flux in its own training data? And I was quite surprised that I do this test every couple of months when new generations are released, and I'm quite surprised to see that it actually knows a lot about Flux. Most of the APIs are at the right version indexed, but if you look at the last 2 in those lists, there is version v1 alpha 1. There was never a v1 alpha 1 of the Flux instance. Never. I never wrote anywhere. There is no such documentation anywhere that that version was ever released and user could use it, right? So it got 80% of the things, okay? I also do is I pick each CRD, then I ask the AI, how can I use this custom resource? How can I configure Flux to do a Helm release and so on? And I'm very impressed that the hallucinations are going down and it's more and more accurate. I don't know if Claude is running on Flux or something, but it's getting really, really good at Flux objects. But this is truly not enough. If you rely only on the data from the training model and you try to do vibe GitOps, you'll fail. I guarantee you. It will not work. Now, I've hooked up Claude to the Flux MCP server, which has the latest docs, has tools for feeding the AI proper documentation latest, and these are, in fact, all the custom resources, all the CRDs that Flux supports today. Right? So it's quite a difference. It missed a bunch of stuff. Right? Now, with the MCP hooked up, and with the AI knowing everything Flux, from this moment on, you can use it as a training tool. I think that's the first thing that I tried with the MCP, build this docs index, then ask questions like, how can I configure Flux this way? I have this workflow. Can you suggest a solution for me to do Helm release retries or whatever? And it's actually good once you have enough context, because the docs are quite huge. And I'm not sure if it can actually generate from scratch a whole repository for hundreds of apps that you'll deploy in an enterprise environment. But from all my testing, and I'm trying to use it almost every day while doing something with YAML, you can actually generate good content, right? The problem is, so how I see vibe coding. I see vibe coding as a comeback of, TDD. TDD is going to make a big comeback, that's my opinion. Right? If you write the tests, or someone smarter than you writes the test, and you just tell the AI to generate the code, and you you have the tests properly according to the specification, it will go into that loop where, it writes some code, runs the test, fail, then it will fix the code and so on. And I think that's something, sadly, that you can't really apply to YAML, right? I mean, of course, you can run some linters or whatever, but if you don't have a cluster, if you don't have Flux, if you don't have the repository or the apps, how are you going to test that? Whatever is generating is okay. So with code and unit tests, I think it's simpler. With YAML data for configuration is a little bit harder. But I think it's still possible to use it as YAML generator, YAML engineer, and you just review stuff. But still, we don't like to review YAML, so maybe we can have another AI that does the review, right? I don't know, AIs on top of AIs, hallucinations. Yeah, okay. So I've shown you a little bit how the MCP can enrich, the AI knowledge around Flux and Kubernetes. This is how we started with it, and this year we kept adding new features, new tools to the Flux MCP. It can, for an existing cluster with quite a complex Flux setup, it can do a really good job of showing what's running, explaining what's running. You can talk to your actual clusters, to your setup, and it can draw dependencies between the apps. It's really good at, how I said it here, GitOps pipeline analysis. Generation and refactoring, as I said, is not there yet, but who knows? Maybe the next version of LLMs will make things even better here. Another thing that I really like about it, that you can use it to onboard new people on DevOps teams, SRE teams, everybody interacts with Flux and Kubernetes. It's a different way of learning. Like, since LLMs, we were used to either go to the docs, read 200 Flux docs pages, you'll get lost, you'll go to sleep. Or you go on YouTube and you watch hours and hours of people doing stuff, right? There are like these two ways of learning and also doing. LLMs have opened a third way of learning. You can ask it questions, you can make it write a small demo for you. It can be way more interactive than what we're used to do until now, learning new technologies. So I think that's very powerful. Other things that it can do, and we never managed to do this with the Flux CLI and so on, is because Flux is meant to be run on every cluster, even if you can run it as a hub and spoke and control all your cluster fleets, we optimize Flux to be very, very lightweight, and we like the idea that there is no single point of failure in your continuous delivery pipeline. So Flux runs everywhere. Once it runs everywhere, it becomes harder to figure out what are the differences between stage and production, or production in region 1 with production in region 2, right? Of course, everything is in Git, is in customized overlays or hand values. Good luck reading all of that, right? It's like, if you have like 10,000 tabs doing this kind of comparison, it's quite challenging. No matter how good your tools are, no matter how many Grafana dashboards you have, UIs, AI is really good at this. Hooked to the MCP, we've built tools so the MCP can switch clusters, query them, then compare all the cluster state, or maybe only one app, one Helm release, and it does a really good job at telling you what the differences are. And I was like really surprised. It was so easy to achieve this with just hooking the MCP and building a little bit of tooling. Now, MCP is just a glorified HTTP server. It's not rocket science. If you build a CLI for your controller with Go, you'll be able to build an MCP server for your controllers, for your clusters, very easily. It's not something extraordinary. But there are challenges with security, and we are going there. And of course, the last thing in this list was the main purpose of us creating the MCP server to help SRE teams during incidents, during production incidents, to generate root cause analysis, to help you troubleshoot, to give you that speed. It can tail logs, look at metrics, compare errors, and so on. So for this is truly valuable. Of course, it can run in local mode. I'm guessing everybody tried this with MCPs. You install the binary locally. In our case, you install it with Homebrew, or you can download it directly from the from GitHub page. You put the binary on your desktop, and then you configure your AI client to use the binary. Now, the interesting thing here is that for the Flux MCP server, the Flux MCP server accesses your disk and reads a single file. And this is our insurance. This is how we've built it. There is a great scare with running random binaries on your laptops. But if you trust us, the Flux team, to run Flux on all your clusters as cluster admin, I'm guessing you could trust us a little that this MCP server will not delete any files will not read passwords. It only goes to kubeconfig. So when you talk to your servers, everything is authenticated through your kubeconfig, right? Some security considerations, especially when you run it locally. As I said, it operates with your existing kubeconfig. You can pass an as some user or as some service account. Maybe you are cluster admin, but you want to use the MCP with lower permissions. So the binary knows how to impersonate something on your cluster and drop the permission from cluster admin downwards. We tried very hard for every response that the MCP server, all the responses, all the content that it sends to the LLM to not contain secrets from your cluster. So it can query anything, but this is the power of MCP. You query, and then you can sanitize the data before you send it to the AI, to the LLM. And what we do here, we basically remove all the secret values. We replace them with star, 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 and that's it. So if you are doing, you are using it in a production system with the Flux MCP, you know for sure that contents in the secrets will never end up in an LLM. Now, I bet you are not using secrets only as Kubernetes secrets, right? I've seen so many people doing in the deployment spec of, Kubernetes deployment, in the environment variable, you paste there your API key. Well, if you do that, be sure that that information will reach the LLM if you query it, right? So if you're using secrets correctly, this masking feature will protect you. Another thing is we have, no matter what RBAC or what permissions you give it to the MCP, there is a flag to toggle read-only mode. And I'm going to explain what that means later on. So the MCP has a small list of tools, and we need to keep it small. I don't know if you've seen the latest issues with, GitHub MCP has, tens of tools, right? It's the tool sprawl. The more MCP servers you install, the more tools are available to the LLM, and the more the confusion. Because all the tools, all their descriptions, everything sits in the context, is part of the system prompt, the initialization of the session. So if you have hundreds of tools, I've seen someone saying on the internet, oh, if you have more than 200 tools, you can't use Copilot anymore. It will not be able to choose the right thing, right? So with the Flux MCP, we don't plan on adding new tools. What we are doing and how we are improving it on the existing tool set, we add parameters. These are like functions. So we add optional parameters. Then in the system prompt, we kind of teach the AI how to use tools which are more complex. And so far, we had good success with this. So Flux MCP has two sets of tools. There are two categories: read tools, which will never change the desired state, right? You don't want to overlap with Flux. If you use GitOps, then you shouldn't be deleting or editing things. And there is that flag read-only that you can set when you start the MCP server and only these tools will be exposed to the LLM. Everything else is being actually removed from the handshake that the client does. But we have also added write tools. AI can control Flux, tell it to suspend, to resume, to reconcile, but also create objects with the same tooling, with the same server-side applied tooling that we wrote in Flux. So you can, play around in your, dev clusters. You can tell it, generate some hand releases for me, apply them, health check them. So these tools are not meant to be used necessarily on production systems, but are meant for learning as well. And you can hook these tools with other MCPs. For example, you work on a setup, you apply it to the MCP, then if you have, let's say, the GitHub or GitLab MCP, you can say, okay, I like this configuration, now open a pull request in my repo and add all these resources there. That's another powerful thing with MCPs, that they can be combined into, and you can build your own workflow. And the last tool here is called Install Flux Instance. This is something that I built before KubeCon. It's a major challenge, like why would you use AI to install something? Like, are you going to pass it the SSH key in the prompt? So then you can install Flux and connect to the Git repo. Of course not. Like, no one should be doing that. But the install tool works a little bit different, where we assume you are doing Gitless GitOps. There is no Git there. We assume you use workload identity on your clusters, so there are no passwords. If you have no passwords and everything is done through OEDC and environment authentication, then you can actually use AI as a way to spin up ephemeral clusters and spin them down. You can say, install Flux from this OCI artifact. And if the cluster has access there, it deploys Flux operator configures all the Flux controllers, and then the whole cluster is being provisioned. And I had some fun with this tool. It's not a replacement for Terraform yet. Who knows? There is also the remote mode. This is where we are investing most of our efforts on the security part right now. We still have in the ingress part at this point auth proxy, our own custom auth proxy. We are trying to get this into projects like the official auth proxy project, which is now part of CNCF. We are trying to collaborate with them and have this auth workflow ready. But meanwhile, we are investing a lot in having the MCP server being able to impersonate outside identities. No matter how we solve the auth problem with Envoy, with some other gateways, this is very specific to Flux. In Flux, when you can assign an identity to your tenants, to your Git repos, and Flux will draw permissions and will impersonate a service account. Now, this should be identical with the MCP server. And it's a little bit more complicated here because all these things that you can use, all this information that you can use to do the impersonation are embedded in the JOT, right? In the claims of the JOT token. And for this, we have come up with a configuration of the MCP when you run it in the server where we are using cell expressions, and we allow you to define expressions, how to extract the right claims, and come up with a target identity inside the cluster. A simple example, let's say you are using GitHub authentication, you are in a GitHub team, and the cluster admin says, people that are in the GitHub team equals dev, they have only read access mode, and assigns a read-only group in Kubernetes authentication. Oh, these are I don't know, SREs, they get cluster admin, right? But there are various ways on how all these SSO providers store this kind of information, group, name, email. So we couldn't come up with a fixed thing, so we use cell expression and allow you to define how to map external identities to internal identities, so the MCP server does the impersonation. Vibe configuration. This is what we want to do, is want to achieve. And I think we have a good workflow to enable vibe coding of YAML and source code of everything, where there are two components here. One is Flux operator, which can scan open pull request or GitLab merge request or Azure DevOps pull request and so on. When you label them with, let's say, preview, Flux preview, the Flux operator will take all the configuration, all the images that are built there. It can create a new cluster, or in an existing cluster, can create a Helm release or a namespace, and that's where it deploys everything from that pull request. So you can vibe code here, commit it to the branch, Flux operator deploys it here in the preview cluster, then it will comment on the pull request, Helm release failed. Timeout 2 minutes. Now what? I vibe coded everything, I don't understand how this stuff works. Anyway, right? So what you can do, you hook up the MCP server, and you tell the MCP server, hey, what's wrong with my application? And there are big chances it will figure out what did you did wrong in the configuration of that application. We tried various ways of playing with this. We mess up with the Docker config file, we mess up with network policies and so on, and running through the MCP, the AI, it kind of figures out, because it can give it access to your source code and your configuration through, let's say, GitHub MCP. The Flux MCP server reads the actual state, can tail the logs, looks at Flux status events, and figures out, cross-checks them, and there is a big chance it will give you the right solution for fixing the preview environment, right? So this is something that helps vibe coding, because you never merge stuff like that, which are not good. You have this preview environment, it's like a buffer of, the garbage that comes in. Okay. This is the thing that I like the most about the MCP server right now is around incident management. We already have good feedback from Flux users, running Flux at scale, hundreds of clusters, where it's very, very hard to, do root cause analysis, and they've seen a major improvement using the MCP server in terms of speed. And after the fact, where everything is fixed, to create a report with the root cause analysis and steps that were performed during the recovery. So it's really good. You rely on the fact that LLMs are really good at writing docs and summarizing and everything. So if you feed it your other informations, other things that you are doing in your team when you are during an incident, maybe, you have Jira tickets, or you use some kind of shared documentation, you can feed also that to the LLM, and together with all the information that's collected from the cluster, with the procedure that you have, all the steps that you have done during the recovery, it's really good at writing this root cause analysis. And this can be used later, and you feed it back to the AI when you have another incident. So you can build an incident response team with intelligence, with this kind of help, I think is really, really powerful, and it should help the SRE teams move way faster. Some things in the roadmap, we want to really improve the docs. We have built full text search index inside the MCP server, and this will be released in 2 weeks from now, where the docs are now embedded with the index together in the binary, so they can work in air-gapped environments. If you, I don't know, you're in a bank and the binary is on the laptop, or MCP runs in the cluster and cluster has no egress, now all the documentation, latest documentation, and this full text search index is embedded in the binary. As I said, we are highly invested into the SSO workflow, where we plan to have support for Google, GitHub, and Microsoft Enter ID by the end of the year, with no need of a special proxy. We want to do everything in an MCP from now. If proxies next year have better support for SSO with MCP, then we can, trim down our SSO integration. And lastly, we want to give cluster admins, especially when you're running the cluster, we want cluster admins to be able to disable tools based on groups. So the same way we do impersonation, maybe you want to say, oh, the devs can have only search docs and get Flux instance, and that's it. So it's a fine-grained access control on tools. Yeah, so if you are excited about what I've said here, please give Flux MCP a try. It's very easy, try it out. Always set the read-only mode. If your kube configs have production cluster, please set read-only mode before you go wild. I did a long time ago a test where it deleted all my nodes trying to fix the CNI. I messed with the CNI. At some point, entering the loop deleted everything. So be careful. It can go wild. So yeah, that's it. Thank you very much.